We have another example on the board. Please notice that this time we have given voltage source and current. Voltage source is given in terms of the sinusoidal equation. So we are going to talk about voltage peak. So if voltage peak is given, most of the time we are going to assume that the current which is given is also peak. If it's going to be specified different, you are going to use RMS values or peak values. What I mean by that, if let's say voltage peak is given and RMS current is given, you're supposed to convert RMS to peak or peak to RMS. You cannot mix RMS with peak, okay? So you're supposed to use one type of the voltage or current. If RMS voltage is given, you're supposed to deal with RMS current. And if voltage peak is given, you're supposed to deal with current peak. So this is peak current and this is peak voltage. Now, we're supposed to find current IC and capacitance and the reactive power. So I'm going to start solving this problem from finding Z total. Ohm's law, right, will allow me to find the total impedance, where Z total is equal to voltage source over I total. Voltage source is equal to 15 volts and divided by I total, which is equal to 5 milliamps. This is equal 3 kiloohms. Please notice that this value of Z total is not complete because we are dealing with the resistor and capacitor. We're supposed to also have the angle. We do not have angle, so next step I'm supposed to find the angle. How I can find the angle? You have to remember the formula for power factor. Power factor is equal cosine of angle theta, where cosine of angle theta is equal for parallel circuit Z total over resistance. I have found Z total, I have given resistance, so I can find very easy angle. So I'm going to solve this part of my formula for angle theta. So theta is equal inverse cosine of Z total over resistance. Remember, write always formulas first, okay? So next, I have inverse cosine and Z total is equal 3 kiloohms over resistance, which is equal 4 kiloohms. This is equal negative 41.41 degrees. This is my angle. Someone is going to ask why I add negative sign, because I'm dealing with the RC circuit. In RC circuit, we are going to have always negative angle next to Z total. So my Z total is equal 3 kiloohms and angle of negative 41.41 degrees. Okay. Now, because I'm dealing with the parallel circuit, I'm supposed to find the total admittance. Okay? Because total admittance will allow me to find the resistance and the capacitive reactance. We need capacitive reactance to find IC. So I'm supposed to write Y total is equal 1 over Z total. Now you can switch your calculators to the mode which allow you to get the answer in rectangular form. Okay, so 1 divided by 3 kiloohms, an angle of negative 41.41 degrees, supposed to give you the answer 250 microsiemens plus J 220.48 microsiemens, okay? So switch your calculators to the rectangular mode, right? And you're supposed to get this answer, where this is my conductance and this is my capacitive susceptance. Next, I can find the current which will go through the capacitor. So I'm supposed to simply write IC is equal voltage source over X of C, right? Someone is going to say, but we don't have yet X of C. So what we're supposed to do? We're supposed to simply write voltage source over, and X of C is nothing else, just 1 over BC. Okay? If you are going to use algebra, you'll rewrite this as voltage source over 1 times BC over 1, which is equal voltage source times BC, which is equal voltage source times BC. I have 15 volts times 220.48 micro Siemens, right? And I'm supposed to add angle of 90 degrees. I'm supposed to get the value approximately equal 3.31 milliamps and angle of 90 degrees. Okay, so this is the current which will go through the capacitor. Next, I'm supposed to find capacitance. Again, you're supposed to realize that we have formula for X of C, which is equal 1 over 2 pi f C. We're supposed to solve this formula for C. So we write that C is equal 1 divided by, open parenthesis, 2 pi f times X of C. Again, someone is going to say, oh, we do not have X of C. So what we're supposed to do? Simply write that this is equal 1 over 2 pi f, and X of C is equal 1 over BC, right? Which is equal to BC over 2 pi f. Okay? Someone is going to say, oh, it's going to be much easier to find X of C. Yes, maybe, but the thing is, I want you to practice, right, calculations also with the capacitive susceptance and admittance and conductance. That's why I'm solving this problem using this way. So next, BC we found is equal 220.48 microsiemens over 2 pi, right? But please notice that frequency is not given. We have given the omega, okay? So we're supposed to write over here omega, okay? 2 pi f is nothing else, just omega. And this is equal 2 times 10 to the 6, of course, radians per second. This is equal 110.24 picofarads. So this is the value, right, of the capacitance in the parallel circuit. Next, we're supposed to find the reactive power. QC is equal 1/2 IC square times X of C. But again, we didn't find X of C. So we can rewrite this as 1/2 IC to the second power times 1 over BC. Okay, because X of C is equal 1 over the capacitive susceptance. So this is equal 1/2. I have 1/2 because we are dealing with the peak values. And we found that IC is equal 3.31 milliamps raised to the second power times 1 over 220.48 microsiemens. This is equal 24.84 millivolt ampere reactive. And this is the reactive power in my circuit. Next, I'm supposed to find the series equivalent circuit. So what I'm supposed to do first, I have to write Z total. We found that Z total is equal 3 kiloohms and angle of negative 41.41 degrees. You're supposed to convert polar form to the rectangular form. And you will obtain 2.25 kiloohms minus J 1.98 kiloohms, where the real part represents my resistance, RS, and imaginary part represents the X of CS, capacitive reactance. We have to find also the capacitance of the capacitor in the series circuit. So what I'm going to do, I'm going to use the formula for the capacitive reactance, which says X of CS is equal 1 over omega CS. Solve this formula for CS and you will obtain CS is equal 1 divided by omega times X of CS. This is equal 1 divided by, open parenthesis, omega is equal 2 times 10 to the 6th power times X of CS, which is equal 1.98 kiloohms. This is equal 252.52 picofarads. Okay, so this is the capacitance in my series equivalent circuit. Next, you can simply draw the diagram. So I have voltage source, right, which has voltage 15 sine 2 times 10 to the 6 t volts, and I have resistor RS, which is equal 2.25 kiloohms. This is the resistance of the resistor. And I have capacitor, which has capacitance 252.52 picofarads. Close the circuit. So we can say that the problem is solved.